Hello friends, I welcome you all in the lecture series for AMVI Mains examination, a complete guide. Today in this lecture, we will be discussing about basic terms and laws of thermodynamics. So let us start with the definitions. As we know that thermodynamics is the study of energy interaction between systems and the effect of these interactions on the system properties. Energy transfer between systems takes place in the form of heat and or work, that we know that. And the thermodynamics deals with systems which are in equilibrium, and thermodynamics is also concerned with macroscopic changes and observations. Now let us have a look on this diagram. As we know that thermodynamics system is defined as quantity of matter of a fixed mass and identify upon which attention is focused for study. Correct. In simple words, a system is whatever we want to study. A system could be as simple as a gas in cylinder or as a complex as a nuclear power plant. Everything external to the system is the surrounding. So everything external to the system, it is called surrounding, and the system is separated from the surroundings by the system boundary. Correct. And universe is the combination of system and surroundings. So these are the basic definitions. Now these thermodynamic systems can be further classified into open systems, closed systems, and isolated system. Open system means what? Mass and energy can be transferred between system and surroundings. Closed means energy can be transferred but mass cannot be transferred. And isolated means neither energy nor mass can be transferred between system and surrounding. Now let us have a look on the closed system. A controlled mass can be considered as a closed system, and closed system consists of a fixed amount of mass and no mass can cross its boundary. That is, no mass enters or leaves a closed system. Here I have given some example. So examples such as piston cylinder device is a closed system. Let us discuss the open system, okay, or a control volume. Open system is a properly selected region in a space, and in this case both mass and energy can cross the boundary of the control volume. Here also I have given the examples such as a water heater, a turbine, and a compressor, etc. Let us discuss the thermodynamic properties. As we know that a system is specified and analyzed in terms of its properties, and a property is any characteristic or the attribute of matter which can be evaluated quantitatively. So the amount of energy transferred in a given process, work done, energy stored, etc. are all evaluated in terms of the changes of the system properties. So thermodynamic property depends only on the state of the system and is independent of the path by which the system arrived at the given state. Hence all thermodynamic properties are point functions. Please note that all thermodynamic properties are point functions. Thermodynamic properties can be either intensive properties or extensive properties. Now intensive properties means what? The properties which are or those are independent of the size of the system as well as its temperature, pressure, concentration, and density. Okay. And another extensive properties are those whose value depend on the size or the extent of the system. For example, volume, area, number of moles, mass, then internal energy, and the enthalpy. So these are the extensive properties. And all of thermodynamics can be expressed in terms of four quantity only, and that are temperature, that is T, internal energy U, entropy S, and heat Q. Okay, now please note that there are two important interaction between system and its surrounding. First is heat can cross into the system and work can cross out the system. Okay, and here it is to be noted that heat and work are not properties of system. Okay, this point is also important, please note this also. Heat and work are not properties of a system. Now come to the main point, that is fundamental laws of thermodynamics. As we know that classical thermodynamics is based upon four empirical principles called Zeroth law, first law, second and third law of thermodynamics. These laws define thermodynamic properties which are of great importance in understanding of thermodynamic properties. Let us see this diagram. So thermodynamic law, in that first, that is Zeroth law, it defines temperature. Then first law, it defines internal energy. Second law defines entropy, and the third law can be used to obtain absolute entropy value. Okay, so third law provides a numerical value to entropy. So the above four thermodynamic laws are based on human observations of a natural phenomena. They are not mathematically derived equation. Since no exception to these have been observed, so these are accepted as a laws. As we know that conservation of mass is a fundamental concept behind this, and conservation of mass means which states that mass is neither created nor destroyed. So let us start discussion on the Zeroth law of thermodynamics. So the Zeroth law of thermodynamics states that when two systems are in thermal equilibrium with a third system, then they in turn are thermal equilibrium with each other. That is, when two bodies have equality of temperature with a third body, then they have equality of temperature. Okay, and this law implies that some property must be same for the three systems, and this property is a temperature. Thus this law is the basic for temperature measurement. Equality of temperature is necessary, and sufficient condition for thermal equilibrium also important, that is no transfer of heat. Okay, here I have given the one example. You can see from this example also you will get the meaning of this Zeroth law of thermodynamics. If A and C are at thermal equilibrium, that is at the same temperature, and B and C are at the thermal equilibrium, then it follows that A and B are at thermal equilibrium, that is at same temperature. Okay, so this is Zeroth law of thermodynamics. Let us discuss the first law of thermodynamics. The first law of thermodynamics is a statement of law of conservation of energy. I repeat, the first law of thermodynamics is a statement of law of conservation of energy. Also, according to this law, heat and work are interchangeable. Heat and work are interchangeable. For a system undergoing a cyclic process, the first law of thermodynamics is given by the change in internal energy of a system is equal to the difference between heat added to the system and work done by the system. This is another statement. Okay, so here the internal energy of a system can be changed by doing work on it or by heating or cooling it, and mathematically first law of thermodynamics we can express as a delta U is equal to Q minus V, Q minus W. Okay, now you can see here also in this diagram I have shown that how the heat transfer and to work by the system or on the system can be expressed. Now here it is noted that the first law of thermodynamics tells us that in order to change the internal energy of a system we must add or remove heat and or do work on or have work done by the system. Okay, so this statement is also important in concern with this first law of thermodynamics. Also here we have to take care about the one more point, that is any system that violates the first law, that is create or destroy the energy, is known as perpetual motion machine, that is PMM of first kind. Or we can say about the first law, that is change in internal energy is equal to energy supplied to system as heat plus energy supplied to system as a work, and mathematically we can express as delta U is equal to Q, that is heat, plus W is a work. Now for better understanding purpose I will give the one example. Okay, you can see here in bank U, that is U like reserves of a bank, and bank accept the deposit or withdrawals in two currencies, okay, that are Q and W, but stores them as a common fund, that is U. Okay, and in this change in internal energy we are writing as delta U, and it is measured in joule or kilojoule. Okay, Q means what? Heat added or lost by the system, and W is work done by the system or work done on the system. Okay, and in general first law of thermodynamics can be considered as a statement of energy conservation for a thermodynamic system. Also heat and work are forms of energy transfer and energy is a conserved. So this may be this can be a statement for first law, and mathematically we can show or we can express as a delta U is equal to Q plus W on. Now here delta U is a change in total internal energy, Q is a heat added to the system, and W on is a work done on the system, or delta U is equal to Q minus W by. Here W by means work done by the system. Okay, about now here important thing is that the sign convention. So the signs on Q and W, it depends on the way the internal energy is changed. If Q and W are positive, the internal energy changes, but if Q and W are negative, the internal energy decreases. And here please note that the internal energy of a system tends to increase if energy is added via heat, and internal energy of a system tends to decrease via work, that is W, work done by the system. Now let us start discussing on processes and cycles. So we know that process means is a successive of changes of state, And here, assuming all the processes are sufficiently slow such that each step or stage of the process is near equilibrium. Certain common processes are isos meaning is equal, and in that first process is the adiabatic means no heat transferred. Then isothermal, for this process constant temperature is there. Then isobaric, constant pressure. Isochloric, constant volume. And important notion in thermodynamics is that of a cycle. Cycle is series of process which returns to its original state. So these are the basic, and the cycle we can consider as a round trip, that is a thermodynamic round trip. Okay. Now let us discuss the adiabatic process. Adiabatic process means what? Here no heat transfer will occur. Okay, and as we know that according to first law of thermodynamics, delta U is equal to Q minus W. But for the adiabatic process, our Q is equal to 0. Then the formula becomes delta U is equal to minus W. Okay. When a system expands adiabatically, then W is a positive. That means the system does work. So delta U is negative. And in the another case, when a system compresses adiabatically, W is negative. That means work is done on the system. So delta U is positive. Now adiabatic processes can occur when the system is well insulated or a very rapid process occurs, so that there is not enough time for a significant heat to be transferred. For example, rapid expansion of gas, a series of compressions and expansion as a sound waves propagate through the air. So these are the examples. Now let us discuss the isothermal process. Isothermal process is a constant temperature process. Okay, any heat flow into or out of the system must be slow enough to maintain thermal equilibrium. That is a constant temperature. And for ideal gases, if delta T, that means the temperature is constant, then the internal energy, that is delta U, will be 0. Therefore, as according to first law, Q will be equal to W. Any energy entering the system, that is Q, must live as a work, that is W. So for isothermal process, Q is equal to W. Okay. Let us discuss the isochoric process. And this is a constant volume process. When the volume of the system doesn't change, it will do no work on its surrounding. So that case W will be 0. And you will get the equation delta U is equal to Q. So heating gas is a closed container and is a isochloric process. Then isobaric process. Isobaric process is a constant pressure process, and here delta U, W and Q are generally non-zero, but calculating the work done by an ideal gas is straightforward. So we will get the formula, that is a W is equal to P into delta V, that is change in volume delta V. And water boiling in a saucepan is an example of the isobar process. Now let us discuss the enthalpy. Now this enthalpy, it is a thermodynamic quantity which is equivalent to the total heat content of the system. Total heat content of the system. And in the analysis of open systems, it is convenient to combine the specific flow work, that is PV, with the internal energy U, as both of them increase the energy of system. So the sum of specific internal energy and specific flow work is an intensive property of that system. So it is called specific enthalpy, that is H. Thus specific enthalpy is given by H is equal to U plus PV. In short letter, small letter also you can represent. And here please note that the heat absorbed in a constant pressure process, it is equals to the system's enthalpy change. So this is about the today's lecture. Remaining part about the laws of thermodynamics we will cover in the next lecture. Please stay tuned for more videos regarding RTO AMVI Mains examination. Don't forget to subscribe to our YouTube channel and press the bell icon to receive notification regarding more videos from this lecture series. So let's crack. Thank you very much. See you in the next lecture.